A triangle has coordinates q, 1, 5, r, 5, -2, and s, -4, 2. Find the perimeter of the triangle. Pythagorean theorem can be used to develop the formula for the distance between 2 points. Let's consider the points A at x1, y1 and B with coordinates x2, y2. First, draw a right triangle with horizontal and vertical legs and the hypotenuse AB. Note that the right angle here has been labeled C. Sides of the triangles can be labeled using the lowercase equivalents of the opposite angle. Here we have then side A opposite angle A, side B opposite angle B, and side C opposite angle C. Recall Pythagorean theorem for a right triangle. C squared equals A squared plus B squared. The C must be the hypotenuse of the triangle. In this case, for our triangle, the C corresponds to the distance between points A and B. The A in the Pythagorean theorem corresponds to the horizontal distance between points A and B, x2 minus x1. The B in the Pythagorean theorem relationship corresponds to the vertical distance between the points A and B. This is y2 minus y1. Substituting this into the Pythagorean theorem formula, we get d squared equals x2 minus x1 squared plus y2 minus y1 squared. Taking the square root of both sides gives us what's called the distance formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Note that for the distance formula, the order that the y and x coordinates are subtracted does not matter. Reversing them would only give the opposite number, which then, when squared, will lead to the same positive number. We then have to use the distance formula to calculate the length of each side of the triangle and add all of these sides to determine the perimeter. For this question, though a diagram is not necessary to determine all of the distances, let's first plot the triangle. Point Q at 1, 5, R at 5, -2, and S at -4, 2. First, let's figure out the distance between points Q and R. dqr will be equal to the square root of the change first in the x coordinates, 5 minus 1 all squared, plus the change in the y coordinates, -2 minus 5 all squared. This gives us the square root of 4 squared plus -7 squared, or the square root of 16 plus 49, which equals the square root of 65. Next, for QS, this will be equal to, again, the square root of the change in the x coordinates, in this case -4 minus 1 all squared, and then the change in the y coordinates all squared, 2 minus 5 squared. This gives us the square root of -5 squared plus -3 squared, square root of 25 plus 9, and this equals the square root of 34. Finally, the distance between point R and S. Again, we have to take the difference between the x and y coordinates and square them. -4 minus 5 all squared for the change in the x coordinates squared, and then 2 minus -2 all squared for the y coordinates. This gives us -9 squared plus 4 squared, all square rooted. This equals the square root of 81 plus 16, or the square root of 97. The perimeter then is simply the sum of all of these sides. Root 65 plus root 34 plus root 97. Or, plugging this into a calculator, we get 23.74 rounded to 2 decimal places.